Using a trigonometric ratio to find an angle measure in a right triangle. Just like in finding a side length, if we have something unknown in our triangle, we can set up a trigonometric ratio and work through. This will be kind of backwards from how we found the side lengths. So let's start off with a right triangle. Here's a nice triangle, here's a nice right angle. Let's say that there is an angle that we want to know the value of. Let's say this angle right here that I'll mark as theta. Just like in finding a side length, we need two pieces of information. It'd be really convenient if we just had the other angle and we could use the properties of triangles, but we said trigonometric ratio in the title, so that means we're going to know one of the sides. We're going to know two of the sides. Maybe this side over here, which is 5.28, and this side down here, which is 3.73. Compared to the angle we are looking for, 5.28 is the hypotenuse, and 3.73 is the adjacent side. The trigonometric ratio that relates the hypotenuse and adjacent side of a triangle is cosine. Cosine of theta is adjacent over hypotenuse. All right. I can do that division on the right-hand side if I want to, but I'm going to save myself some number crunching and punch everything into my calculator at once. I need to find the angle whose cosine gives me this ratio. Thinking back to what we were doing with logarithms, I need to find the inverse of the cosine function. And for reasons that we'll get into later on in the course, cosine doesn't really have an inverse. It turns out that cosine is not a one-to-one function. But within the context of a right triangle, we can restrict the domain and pretend that it's a one-to-one function, which means that we can define theta as the inverse cosine of the ratio 3.73 over 5.28. Inverse cosine is a feature built into your calculator, where it is varies strongly from calculator to calculator. Just like in calculating using the cosine itself, in calculating with the inverse cosine, if you want an answer in degrees, make sure your calculator is in degree mode, and we'll just punch in the inverse cosine of 3.73 divided by 5.28, and the calculator is quite happy to spit out that theta is 45.1 degrees. Right? 45.05405188, but we'll round it to 45.1.